Let's pick up with number 7. It says write the equations of all horizontal asymptotes for this function here. Horizontal asymptotes are asking about the ends of the function, right? Do the ends flatten out? So really we're saying find the limit as x approaches positive or negative infinity of this function. And the way we find or evaluate limits to infinity is we ask where the highest power is. And overall, the highest power is in the denominator. And if the highest power is in the denominator, the limit to infinity is 0, which tells us that the ends of this graph, who cares what it's doing in the middle, are eventually flattening out to y values of 0, meaning our horizontal asymptote is the line y equals 0. Number 8 says determine the constant a that makes the following function continuous. It does not say differentiable, it just says continuous, meaning we need the two pieces to meet at x equals 2. So we're going to make the y values match when x equals 2. This says y equals 2x cubed plus 1. And y equals x squared plus a. I need those to be equal to each other when x equals 2. So we'll go plug a 2 in for that x, and we'll go plug a 2 in for that x. So let's see, we've got 2 times 2 cubed plus 1 equals 2 squared plus a. And so we have 16 plus 1 equals 4 plus a, or a equals 13. All right, let's take a look at number 9. Number 9 says find the average rate of change of this function on the interval 4 to 9. Rate of change means slope, so they want the slope on this function between 2 points. This is an Algebra 1 question. Right? If we want to break it down that way, we have 2 x's, and if I want to find the slope, I need 2 y's. So I want to plug the 4 in, and I want to plug the 9 in. Now we have a formula for this. It's f of b minus f of a all over b minus a. So I'm not going to be taking the derivative, I'm just finding the slope. So I want the y value at 9. Oh geez. If I plug in a 9, I get 81 plus 3. Minus, if I plug in the 4, I get 16 plus 2 all over 9 minus 4. And that should do it for us. So I have, let's see, 84 minus 18 all over 5. That should do it for us. Okay. Was that 66 over 5? Yeah. So let's take a look at number 10 and 11. Number 10, d dx. Find the derivative of this function. So if I want to find the derivative, the first thing I'm going to do is I'm going to rewrite this. This says x divided by 3. I'm going to slide that 3 out and call it 1/3 x. Plus 2 over 5x squared. I'm going to call that 2/5 x to the negative second. And then everything else can stay the same. So now I can take the derivative. So I'll say y prime equals the derivative of 1/3 x is just 1/3. Here the power rule says bring that negative 2 down in front and get a negative 4/5 x to the negative third when I subtract 1 from the exponent. The derivative of 2x is just 2, and the derivative of negative 1 is just 0. Good. Let's take a look at the next question. Similar notation, that's why I started talking about them together. So d dx means the first derivative. This one means the third derivative. So I don't think we need to rewrite this. This is already written as powers. So here we go. We can say y prime is equal to 2x minus, we bring that 4 down, we get 8x cubed. Y double prime, the derivative of this, gives me 2 minus 24x squared. y triple prime, the 2 goes to 0, and then I'm left with a negative 48x to the first.